today we're going to be talking about inversion. So, inversion is a reflection in the line of y equals x. So, in this line of y equals x, every coordinate has identical numbers. So, the coordinates in this line are things like 1, 1, 2, 2, -5, -5, etc. So I just went and plotted some of these points here. So this is our line of y equals x, and again, inverting a graph is the same as reflecting it in that line. For example, let's take the function x squared f of x equals x squared minus 4. So we know that the squared makes this a quadratic function, so it's going to be a parabola. And we know that this -4 means that it's going to be moved down 4 units. So I'm just going to go ahead and sketch that. And we can also pop some arrows on this guy because we know it goes on forever. So that is our function of x squared minus 4. So you can see, yes, it is a parabolic shape. And we also know it's going to intersect at 2 and -2 just from factoring it out. So our x-intercepts are -2 and 2, and this is our vertex at 0, -4. So now that we have our original function drawn, we're now going to invert it. So I always like to start by grabbing a few key points from our original graph. So like I said before, our vertex is at 0, -4. And we have two x-intercepts. One is at -2 and one is at +2. So here are some of the key points on our graph. Now the next step to invert it is we're going to switch the x and the y points in each coordinate pair. So 0 is going to become -4, and -4 is going to become 0. -2 is going to become 0, and 0 is going to become -2. So yeah, you're simply just switching the coordinates around. So the ones in blue here are our inverted coordinates. Now I'm going to go ahead and plot the inverted coordinates. So we'll have one here at -4, 0. We'll also have one at 0, -2. And at 0, 2. Now that we have our points, we can kind of see a rough sketch, and we can go ahead and connect these points to get that parabolic shape. Now that we have drawn the inverse of our function, we can see that it really isn't a function at all. We can figure out if something is a function by doing something called the vertical line test. So if you take a ruler and you place it over the graph, over our inverted graph, you can see that every time I put the ruler down, it's crossing the graph twice. This means that our inverted graph isn't a function. If you remember from grade 10, a function means that it has exactly one output for every input. So you can always check if something is a function or not by performing the vertical line test like I just did. So now that we know that our inverted function isn't actually a function, we want to ensure that when we invert it in the future that we're going to get a function out. So we can do this by restricting the domain. So I'm just going to go ahead and erase this. So our original graph is this one in red here. And the domain on our original graph is x such that xer. So this graph can go to the left and to the right forever. Now, if we want to restrict this graph, we're going to basically cut it in half. So here's our vertex. So this is the middle. And we're either going to take out everything on the left side of the graph or everything on the right side of the graph. So what that means is we can either only include values that are greater than 0, or we can only include values that are less than 0. So you can choose either. It does not make a difference. I'm just going to go with x is greater or equal to 0. So that means our new domain will be x such that x is greater than or equal to 0, and it's still an element of the real numbers. So this is our new domain. So like I said, since I'm only keeping numbers that are greater than or equal to 0, everything that is less than 0 is gonna disappear. So now we only have the right side here of our red graph. Therefore, once we have this graph and we're going to invert it, this line here of the other graph is going to get erased. So again, in red is our original, and in blue is the inverted. Now I'm going to grab my ruler again for the vertical line test. And as you can see now, the ruler only crosses the graph once at each point, which means that our inverted function really is a function.